Okay, so today we are continuing with our what we started last Friday before our snow days, which was the Pythagorean theorem. You remember that?
Yeah.
Okay, we kind of went through an activity where we filled in some tables and we looked at some triangles and that kind of stuff, and figured out how the Pythagorean theorem kind of works. Do you remember the formula for the Pythagorean theorem?
A equals B, A squared equals B, A squared.
A squared plus B squared equals C.
There we go. You're trying. A squared plus B squared equals C squared. Okay, and listen, this is a formula, right? This is the basic form of the formula. And just like when we've had formulas in the past where we have y, like this is a formula that we've used a lot, right? Y equals mx plus b. I don't have to use those letters, right? The y's and the x's can be different letters and those kind of things. So we're going to end up seeing some problems where we have different letters to use, but we need to understand what the A, B, and C represent so that we can put letters in the right place when they belong there. Okay, so the A and the B are always the two sides of the triangle that are going to make the right angle. Just like we have here on this first example, that's A and that's B, and they make the right angle. And then C is going to be the side that's opposite or away from the right angle, and that's going to be called the hypotenuse. It's one of the funnest words we get to say in math, hypotenuse. Okay, and so A and B, sometimes called sides, sometimes called legs of the right triangle. A and B will always make the right angle, and then C will always be the side opposite. So if they happen to relabel this triangle, and instead of sides A, B, and C, we had sides W, X, and Y, okay? We can still use the same formula. We understand that W and X are making the right angle. So instead of ABC, we would use W squared plus X squared equals Y squared. And that's the same thing, right? Does that make sense? Okay, Med.
Does it matter which like A or B is first?
Excellent question. It does not. And sometimes they're gonna give you a picture of a right triangle, and it's gonna look like this, and they're gonna tell you, this is your right angle. And they're gonna say like this is 7 and this is 4, and we got to find this side. It doesn't matter which one I label as 4 and which one, I could label it as A and B, or I could switch those around. It doesn't matter at all. That's a great question. Okay. All right. So I'm getting rid of all that because that's just kind of setting us up for what we're going to do today. We're going to use the formula to find the missing side lengths of the triangles on this page. All right. So the formula A squared plus B squared equals C squared. So I'm just going to fill numbers in. So A squared would be square root of 10 squared plus B squared, that's square root of 40 squared. And then it equals C squared. What is the square root of 10 squared? 10. And the square root of 40 squared is 40. So that equals C squared. 10 plus 40 is just 50. C squared. And then when I want to get C by itself, I want to get rid of that exponent, so I just put the square root symbol around it. Then the square root and the squares 2 cancel each other out, so that gives me C. So C is the square root of 50. Since A and B are written as square roots of whole numbers, do you suppose we ought to just leave our answer that same way? So C is just going to be the square root of 50. We don't want to approximate this and divide it on the calculator and find that it's like 7.1 or something, right? Because that's the way our problem is set up. Okay. All right. Now then. Number 2. What's different about number 2? Faith.
You're not finding C, you're finding B.
This time we're not finding C. We already know what C is, but we can still use the formula. The formula works the same way. I'm going to switch. Maybe if I can see my screen there. There we go. Switch screen colors so we don't run together here. But it would be square root of 8 squared plus B squared equals square root of 26 squared. Just like the last one, the square root and the square symbols cancel each other out. They vaporize each other. So we have 8 plus b squared equals 26. And then what do I do next?
Divide.
Subtract 8.
Oh, subtract.
So b squared equals 18. Take the square root. And again, square root of 18 does not give us a whole number, so we'll just leave our answer. B is the square root of 18. There's kind of a little shortcut or a little pattern that you can see here when we're dealing with numbers that are all square roots to begin with. Can you see it? Okay. When you have A and B, and they're both square roots, what do I do to find C? Just add those together. Square root of 10 plus square root of 40. Okay, just add those two numbers together. 10 plus 40 is 50, square root of 50. When I have this, when I have C, just subtract the side that you got. So 26 minus 8 is 18, and it's just the square root of 18. That only works if you have the square root symbols involved with all the numbers, by the way. If we take away the square root symbols, then things get a little bit different, which we're going to see on the next problem. So, but that's just kind of a little trick or a little shortcut you can see if you're dealing with numbers that are all square roots, okay? All right, let's do number 3. What's different about number 3?
It's written out.
It's written out instead of having a picture. Do you like having pictures?
Yeah.
Yeah.
Draw one. If you like to have a picture, draw one. I don't care. Look at that. See how easy it is to draw a right triangle? And then I've got side links that are 2.4 and 6.5. Does it matter that my drawing's not to scale or that I might not actually have 2.4 centimeters there? No, it doesn't matter at all. All it is a picture just to help you understand what's going on. So it said the sides are these links, and the sides always make the right angle. So I've put my sides in the right place. And now we're looking for the hypotenuse. That's the side opposite the right triangle or the right angle. So this is C.
Why do you put the little box where it is?
That's just a symbol to let you know that this is a right angle. Anytime you see that box in an angle, that is the signal that's telling you it's a 90-degree angle. That's what that symbol means. So anytime you see any shape, whether it's a triangle or a square or a rectangle or whatever, if you see that little square in the corner, that tells you it's a 90-degree angle. Okay, so 2.4 squared plus 6.5 squared equals C squared. And then, guys, I don't know if you know this or not, but calculators are awesome tools. I suggest that you use them. Oops. So, all right, 2.4 squared is 5.76. Oops. So 5.76 plus 6.5 squared, 42.25, equals C squared. Now we just add these two together, 5.76 plus 40, oh shoot, 5.76, I already had the other one in there, oh my goodness. All right, start over here. So 42.25 plus 5.76 equals 48.01.
So that side is 40. Oh, the picture doesn't matter.
Got to do the square root. Now, since our numbers are given to us as decimals rounded to the nearest tenth, what can I do with my, I can approximate this one. I can do square root. And I can say C is approximately 6.9 centimeters. Your answer should match the problem that is given to you. If they give you a decimal, then give your answer as decimal. If they give you square roots, Leave your answer as a square root. Okay, number 4. A right triangle, get rid of this thing here. Right triangle has a side length of 1/4 and a hypotenuse of 1/3. So if we drew our picture, so a side length of 1/4 and a hypotenuse of 1/3. Okay, so we would do 1/4 squared plus b squared equals 1/3 squared. I put my fractions in parentheses because if you write, like if I write 1/4 squared, people might think that means 1 squared over 4. But we need to put the parentheses around it so that you know the entire fraction gets the exponent. Does that make sense?
Yeah.
Okay. So 1/4 squared is just 1/4 times 1/4. What is that?
1/8? No. 1/16.
1/16. 1/16 plus b squared. And then 1/3 times 1/3 would be 1/9. 1/3 times 1/3. 1 times 1 is 1. 3 times 3 is 9. 1/9. Okay. All right. Now, again, with the calculators, these gray calculators that we've got in the room here do fractions great. But if we subtract 1/16, 1/9 minus 1/16, I would type that straight into a calculator because that's an ugly one. It comes out to b squared equals 7 over 144.
Wait, why is it minus 1/6?
1/16. I think I just missed a line there. Minus 1/16. So now, square root, this is about as ugly as they get here doing this fraction. Square root of 7 over 144 is the same thing as the square root of 7 over the square root of 144. And the reason I separate them out like that is because 7 we can't do a square root of, but 144 we can. So what is the square root of 144?
12.
12. So this is a weird answer. And I should label it, it's centimeters, okay? Square root of 7, I guess it doesn't label, so I thought it was the last one that labeled centimeters, so this one does not label, actually. So no label on this one, my bad.
Or you just put units.
You could put units. But 7 square root over 12 is the way that should be written as the simplest answer, okay? Definitely one that you would not turn into a decimal, and you would certainly not turn square root of 7 into a decimal and leave it as a fraction in part of that. That's a big time no-no. Okay, so this really is the only way this answer could be written and be acceptable. All right, hopefully we don't get into too many that look this bad. This one, fractions in the first place make you guys cringe.
Yeah.
And then when they come out to weird fractions like this, that makes it even worse. But hopefully we'll be okay. All right, everybody good there? I need to erase that so I have room to work the next one. We good? Okay. That's the button I want. Okay. So for this one, we need to find the value of x, which is this value right here. But in order to do that, I need to use this leg and this hypotenuse to find the length of this leg, which we'll call b. And then once I know what b is, I can use b and the hypotenuse here to find x. Okay, so we've got to do this in stages here. We've got to find one thing first so that we can use that value to find the next thing. Okay? So 5 squared is a plus b squared, that's the side I'm looking for here, equals square root of 34 squared. So that would be 25 plus b squared equals 34. You with me so far?
Mm-hmm. So minus 25.
Minus 25. So b squared equals 34 minus 25 is 9. And then take the square root of both sides of that equation. So b equals square root of 9.
Which is 3.
3. Good. So b equals 3. So that tells me this side length right here is 3. Now I need to do this. It's the exact same steps. It's just using a little different numbers. So instead of having square root of 34 and 5, I've got 3 in the square root of 18. So I would do x squared plus 3 squared equals square root of 18 squared. So that would be x squared plus 9 equals 18.
Why is 18 squared?
Because that's the formula, a squared plus b squared equals c squared. So we have to square it for the formula to work.
So now minus 9 squared would be 3.
Well, the square root of a number squared is just that number. So we did square it. Yeah, it is squared. That's why the symbol went away. Both symbols canceled out. So subtract 9. So x squared equals 9. Take the square root and x equals 3. That one comes out nice and neat. I like that one. I like all of them in this. This kind of math right here is some of my favorite stuff we get to do in pre-algebra.
The B and
Yeah.
for 3.
They were both the same length. A and or B. Yeah, the two missing side lengths were both 3. Okay. Now then, let's look at the next page. I like this one
I
a
don't
lot.
like this. This looks scary.
No, it's going to be fun.
No,
Looks
like
a
not.
shell.
Okay, it does look like a shell. It looks like a snail or a conch or something. I don't know which
Looks
color
like
it's
a
in.
spiral
All right.
staircase.
Yeah.
It does look like a spiral staircase. All right.
I mean, that would be a weird.
So now then, you understand what's going on here. They give us the first two measurements here. They give us this side length is 1 and this side length is 1. So we need to find this hypotenuse. And once we find that, then that hypotenuse becomes a side length for this triangle. And we're going to always have a side length of 1 all the way around, right?
Well,
But the hypotenuse that we find using our formula is always going to become one of the next legs. So we just got to work our way around the spiral here until we figure out what x is.
This is a lot of
Okay. All right, hold on. You don't get you're on the right track, but don't get too far ahead. So 1 squared, that's a squared plus b squared. 1 squared plus 1 squared equals c squared. That's going to give me this hypotenuse right here. Okay, so I need to erase that because I'm going to need that room here in a second. All right, so 1 squared is 1 plus 1 squared is 1 equals c squared. So that is 2 equals c squared. So give me the square root of 2. So square root of 2 equals c. So this one comes out to be square root of 2. We're just going to leave it like that. That makes life easier, believe it or not. Okay, now I need to find the next one. The next one is square root of 2 is now this side length and 1, and I need to find that hypotenuse. So it's the square root of 2 squared plus 1 squared equals c squared.
So you have to do that for every single one.
Yes, we get to do this math all the way around the spiral.
It's pretty easy once you get the hang of it.
It you know, it's not too bad. 2 squared is 2 plus 1 equals c squared. So 3 equals c squared. Take the square root. Square root of 3 equals c. So that one's going to be the square root of 3. Now we've got the leg length for our next one. So we've got 1 squared plus square root of 3 squared equals c squared. So that would be 1 plus 3 equals c squared. 1 plus 3 is 4 equals c squared. Take the square root. And so square root of 4 equals c.
Wait
Wait a minute, Alec, what do you notice?
It's just going up by 1.
Square root of 2, square root of 3, square root of 4. What would you say the next one is?
5,
Square root of 5. I think you're right. Then, so what's x going to be?
14. Wait,
7, 8, 9, 10, 11, 12, 13, 14, 16.
Square root of 16. So x equals square root of 16, which is
4.
4.
oh, that's a lot easier than it seems.
It's a lot easier than it seems. Guys, look for patterns. Patterns are so helpful in math. I mean, you have to go far enough to establish that the pattern is going to work. You can't just get here, square root of 2, and then just assume, oh, it's 3, 4, 5. You have to go a couple of steps and establish a pattern. But you can find patterns to work problems like this. All right. Our assignment today is this guy right here.
We have an
Oh, yeah. But hey, listen, I didn't tell you what we're doing the rest of the week. So today we're doing a lesson and an assignment. Tomorrow, now, how many of you guys in this hour got F's on the test? Nobody. Nobody in this hour. I told you guys when I handed it back, nobody in this hour failed it. This is my only hour that I had no F's.
Because we're big brain.
Because you guys are freaking
Genius.
geniuses.
Genius.
Okay?
Didn't fail.
All right. So now, that doesn't mean, though, that there weren't some grades that could have been improved, because I did have some D's, right? Okay, there's some grades that could have been improved. So, but I had in some of my other hours, holy smokes, guys, I had lots of people with some F's in some other hours. So tomorrow is going to be a test, makeup, catch up, correction, retake, make up points day.
I have a B in this class now that I don't have a C.
No, but you don't have it.
Now that I don't have a C, I have a B. That's going the right direction, because it could be a D, right? You could have, all right.
Wait,
Okay, so tomorrow is going to be a test kind of correction makeup day, which will affect fewer people in this hour than any of my other hours, but still a few of you can do some work and get some extra points back. Friday is going to be a PLT day. So this is our only homework for the week. Okay? Jackson, hand these out, please.
For
we don't
more.
have school next Friday.
I know. Or the next Friday, or the next Friday, or the next Friday.
And then spring break.
That is, well, that's, next Friday is a teacher work day. The next Friday is a teacher work day. The next Friday is the makeup day for parent-teacher conferences. The next Friday is spring break. So literally 4 Fridays in a row that we don't have school.
Wait, so I got one wrong. Do I get to take that one again? Or, like, should I take do you take the whole thing, or do you just take the questions that you got wrong?
No, because I don't have to retake it, and I got like a B.
Oh, what?
Other than
Yes.
I'm at 111 in the class that I don't like the most.
What is it?
Intro to engineering.
You. I'm gonna take that last.
Yeah, for
They
some
have
reason
to
I'm
take
at 111 because I took some extra credit that I didn't know I did.
I never do. Just kidding. Actually, I never do.
Maybe I'm 5'2" then.
You going good?
All right.
5% though.
Okay. I'm sorry, what?
What?
I will, McKenna, let me get started on this
Oh, I
first
need
real
one.
quick. Okay. We're gonna get, I'm gonna just set you up on a couple of these.
Bro, this looks hard.
It's not. It's just using the formula that we just did. Okay. You guys on Zoom, listen. Go to Google Classroom, to the classwork tab. I'm going to show you real quick. Go to the, oh, wait, I'm still recording. I got to stop that real quick. I'll have to, hold on just a second. I can't figure out how to stop. Okay, I'm going to have to, oh my goodness. Where's the QuickTime button? There it is. Oh my goodness. Okay.